Hey guys, so here's your guys' Edpuzzle video and it's going to be on proofs with complementary and supplementary angles. So just make sure before you guys start writing your notes in your notebook, you need to write down these tables of contents because again, I will be grading these notes eventually, probably soon. So make sure you guys have this new information, which is homework number 10, Edpuzzle proofs with complementary and supplementary angles. Okay. Now, go to a new page in your notebook, and of course, again, you guys, the beginning is going to be a lot of writing down definitions, understanding those definitions, and then applying them to the proofs that we will do at the end. Okay, so reasons to be okay. So on the left hand side, you guys, those are going to be your reasons for your statements. That's why I wrote reasons to be used in proofs. So we'll talk about the first one, and it's definition of complementary angles. And on the red, you guys, those are all ways you can shorthand writing them. So for example, definition of complementary angles, shorthand is definitions of complementary angles. So that's just for you guys to know. Now, when we're talking about the definition of complementary angles, so there are multiple ways that we can use this reasoning. And for starters, you guys know complementary angles are when they add up to 90 degrees. So one example would be, if we had a statement and it said something like, angle 1 plus angle 2 is equal to 90, right? Then I could say, so somewhere down the line, I should be using definition of complementary angles, because that's literally what complementary angles are, right? Two angles that add up to 90. Or if you see for some reason, they say this as the statement, right? Then you can say, I can say angle 1 and angle 2 are complementary angles. Why can I say that? Because that's literally the definition of complementary angles. Next one, definition of supplementary angles. So you guys know, supplementary angles are when you add two angles that add up to 180, right? So if I saw this, then I would say, I would say 1 and 2 are supplementary angles. Why? Because that's literally the definition of what supplementary angles are. Okay? Then we have definition of linear pairs. So, you know a linear pair is when there's a straight line and you have two angles that make up that straight line, right? So, you can say, if there's a statement that says angle 1 and angle 2 are sublinear pairs, so if that's the statement, then you say, I make that statement because the reason is definition of linear pairs. We know that angle 1 and angle 2 are linear pairs. Okay? Alright, linear pairs are supplementary. So, if we have this statement already, that 1 and 2 are linear pairs, then you guys can use linear pairs are supplementary by stating, if angle 1 and angle 2 are linear pairs, then we can automatically say angle 1 and angle 2 are supplementary angles. Reason? Because we know linear pairs are supplementary. And that's why I wrote in purple, you guys. This reason, if you ever use this reason, linear pairs are supplementary, it comes right after you say definition of linear pairs. Next one, we have definition of right angle. So if we have this statement that says a right angle is 90 degrees, then we can say, the reason for that is its definition of right angle. A right angle is 90 degrees. Next one, so we have the angle addition postulate, So what the angle addition postulate, you guys, it sounds exactly how it sounds like. You have two angles that add up to a bigger angle. So when you guys look at angle XYZ, so angle X, angle Y, and angle Z, which is this straight line, right? That's angle XYZ, which is 180 degrees. It makes sense that, oh, this angle plus this angle adds up to 180 degrees. So that's what the angle addition postulate is. Two angles that add up to a bigger angle. Angle addition postulate. And lastly, we have the substitution property. So the substitution property is, if A is equal to B, then you can substitute B for A in any expression. So it's literally substituting. You're just substituting. If A is equal to B, you can substitute B in for A anywhere, or you can substitute A for B anywhere. So these are the definitions we are going to be using, you guys, for your guys' proofs today and for tomorrow, or sorry, not tomorrow, for Friday. So you guys are going to be using these definitions in your proofs. And again, you are not going to understand it right away. It takes time. Proofs is a progression. It's a progression. So as long as you guys truly understand what those definitions are and you can identify those definitions, it should help you along with the proofs. So we are going to apply it right now. So at any point in the time, just pause the video so that you guys can get in the notes down. Alright? Okay, so here is example 1. Here's example 1. So, given TVK is a right angle, we have to prove angle 1 and angle 2 are complementary angles. So, there are the statements. Now you guys have to provide the reason, and I provided you guys with the reason for all the ones above. So, number 1, we have given. Okay, that makes sense because that's literally the statement we gave. Alright, now you have to think, measurement angle TVK is equal to 90 degrees. So why can we say that? Why can we say measurement angle TVK is equal to 90 degrees? Well, in number 1 statement it says angle TVK is a right angle. What do you know about a right angle? Oh, a right angle is 90 degrees. So in the next statement, the reason why we can say measurement angle TVK is equal to 90 degrees, because that is the definition of right angles. So because we have angle TVK is a right angle, well, if it's a right angle, then we know it's angle TVK is 90 degrees because it's the definition of what a right angle is. Okay, next, so now we have to try to think, right? How do we get from step 2 to step 3? Well, in step 2, in step 3 it says angle 1 plus angle 2 is equal to angle TVK. So we have to try to think about it, right? Here's angle TVK, right? So how come we can say this angle plus that angle is the whole thing? Look at your notes from above. It's because that is the angle addition postulate. That is the angle addition postulate, right? Because angle 1 plus angle 2 is equal to the bigger angle, right? Angle TVK. So that is the angle addition postulate. Now let's look at 4. We have angle 1 plus angle 2 is equal to 90 degrees. So how do we get that? Well, this is something for you guys to notice. Do you guys notice how angle TVK is equal to 90 degrees, right? And do you guys notice how angle 1 plus angle 2 is equal to angle TVK? In 2 and 3, they both had angle TVK, right? So we can substitute from from statement 2, we could substitute that 90 for angle TVK in the third statement, right? Because they're the same. So what's the reason for that? We can put this in for here. And the reason for that is it's the substitution property. It's substitution from which lines? 2 and 3. Right? Since 90 is equal to TVK, we can substitute 90 in for there, which is how we got 4. And then lastly, okay, so look in step 4, you guys, we have angle 1 is plus angle 2 is equal to 90. Angle 1 is complementary to angle 2. Why can't we say that? Well, angle 1 plus angle 2 is equal to 90, you guys. Doesn't that say if those two angles add up together to each other, then it's 90? That's literally the definition of complementary angles. And then you are done. So, right, you guys have to understand those definitions above to help you with your proofs. And again, it is not something you are going to get right away. It is something that you guys have to just be exposed to and practice over and over and over again. And then as you guys practice and persevere, it should get a lot easier. Okay, so here's example 2. And again, pause the video, you guys, so that you can get it down, so that once you write everything down, then you can listen to my words to really comprehend what's going on. Okay, given angle ABC is a straight angle, right? Prove angle 1 is supplementary to angle 2. So we have 1, and it says angle ABC is a straight angle. Well, that's given. Okay, so now this is where we have to think about it, right? Angle 1 plus angle 2 is equal to angle ABC. So this is angle ABC, and it's saying this angle plus this angle is the whole angle. Where have you guys heard that? That is the angle addition postulate. And you guys can shorthand the angle addition postulate if you want, but I'm just writing it out so that, you know, not all of you are comfortable with the shorthand yet. But that makes sense, right? The angle 1 plus the angle 2, those angles combined is equal to the straight angle, right? So that's where we get the angle addition postulate. Now it says angle 1 and angle 2 form a linear pair. Angle 1 and angle 2 form a linear pair. Does that make sense? Yes, it does, right? Because if you guys just look at the figure, that is literally what a linear pair is, right? It is two angles that share a common side and that have the common vertex, and it's on a straight line, right? That's literally what a linear pair is. So it's saying, the statement saying angle 1 and angle 2 form a linear pair, that is the definition of linear pairs. And it's in your notes from above, right? The definition of linear pairs. Number 4, angle 1 is supplementary to angle 2. Well, you guys, if we know it's linear pairs, right? If we know it's linear pairs, then we know, oh, linear pairs, those are supplementary. So this is just linear pairs are supplementary. So that's the end of the video. Again, right? This is a progression. So you guys just have to get used to the definitions, know the definitions, and when to apply the definitions in your guys' proof. We will be practicing this on Friday, so be prepared and good luck, okay? Again, write these notes in your notebook, take a picture of your notes, and submit it to Google Classroom by today. Alright. Peace.